Hi guys, I'm Yuki from External Level Japan at Solana Foundation. If you ever swapped a token on Solana, you probably use Jupiter, maybe without even knowing it. Jupiter is a router that quietly finds you the best price across the entire chain. In the next 10 minutes, I'll show you exactly how it does that using an interactive lab, 1 idea at a time, each with a little toy you can play with yourself. Now, let's dive in. On Solana, the same pair, let's say USDC to JUP, is sold in dozens of different shops. We call them DEX. Each shop has its own price and its own depth. How much it can feel before the price starts moving against you. Here is how to read each bar. The green is what you actually receive. The striped part is what price impact eats away. So, the longest green bar wins and it gets the crown. Now watch what happens as I increase the order size. For a small order, the cheapest shop wins. But as the order grows, the crown jumps to a different shop, the deepest one, because the cheap shop is too shallow and its price runs away from me. That's a core problem Jupiter solves. The best shop changes with your order size, and no human can track that live across dozens of venues. So why does the price move at all? That's price impact. Let me show you side by side. On the left are the bars, the ideal amount versus what you actually get. On the right, this gauge answers the question, why do you get less? It shows how far below the fair rate you land. The bigger your order is relative to the pool, the further that needle drops. And here is a key move. Instead of buying from one pool, Jupiter splits the order across several. Watch the gauge recover and the green bar grow. Same spend, but you keep more tokens because splitting spreads the impact thinner. Sometimes the best path isn't direct at all. Say you want to go from Bonk to JUP, but the direct pool is thin. Instead of forcing your trail through that thin direct pool, Jupiter hops through a deep hub like USDC. It's two swaps instead of one, but each swap happens in a deep pool. So, you arrive with more JUP than the direct route it would give you, like this. And here is the magic. Both swaps happen in a single transaction. We'll come back to why that matters at the very end. Let's go back to splitting, but how much goes where? It turns out it's not equal, and this is my favorite visual to explain why. Think of each pool as a water tank. The width is its depth, and the water level is how crowded it gets as you pour money in. If I split equally, the small tank overflows, like this. Its level shoots up and I lose tokens. If I pour everything into one, then, like this, then that single tank overflows instead, like this. But the optimal split runs every tank at the same water level. That balance is the best you can possibly do, and it's exactly why the real numbers come out uneven, like 64, 26, and 10. Not a clean third each. Deeper pools get more, shallower pools get less. So who actually finds that perfect split? Jupiter's routing engine. This curve shows your received amount for every possible split between two pools, and notice there is a clear peak, the single best split. The older engine called Metis searched more closely, like this. Here, we picture that as a cross grid. It's fast, but it could run next to the peak and miss the exact best point. The current engine, Iris, uses smarter math, like this. Golden section search and blends method to home right in one peak, splitting as finely as 1/100th of 1%. Jupiter says that's roughly 100 times faster than the old engine. Iris is what's running today. Metis was retired in late 2025. And you can see it right here in the table. Iris runs closer to the true peak, so you simply receive more. Here is where modern Jupiter gets really clever. It doesn't only check its own pull routes. It asks 3 kinds of sources at the same time. 1. Its own on-chain route through Iris. 2. A direct dealer quote called Jupiter Z. That's RFQ, a firm price from a market maker with zero slippage. And 3. Third-party aggregators like Deflow and Hashflow. What's the crown? For small orders, the in-house route wins, but as the order grows, in this example, the zero slippage RFQ pulls ahead because it has no price impact at all. Comparing all of these on every trade is called meta aggregation. Basically, an aggregator of aggregators. Last piece, all those hops and splits we just saw, they run as one single transaction on Solana, one ticket, all or nothing. Let me force a failure in the middle of the route. With atomic execution, if any step fails, the entire thing reverts. Your USDC just stays safely in your wallet. No loss, no mess. But if these were separate transactions, you will be stuck, stranded in some intermediate token halfway through. That's the exact danger atomic execution removes. One catch: a Solana transaction has a strict size limit, 1,232 bytes. A complex route touches a lot of accounts and every address is 32 bytes, so it fills up fast. Jupiter's trick is the address lookup table. Store the addresses once on chain, then reference each one by a tiny 1 byte number. Then watch the burr. Without it, complex routes overflow the limit, like this. With it, they fit comfortably. So that's Jupiter end-to-end. Scatter liquidity, price impact, multi-hop routing, the optimal split, the Iris engine, meta aggregation, and one atomic transaction to run it all safely. Every number in this lab is illustrative, simplified to show the mechanism, but the idea are exactly how it works under the hood. The lab is linked in the description, so you can play with every one of these yourself. If it helped, a like and a subscribe go a long way. Thanks for watching. See you in the next one. Bye.